informal presentation, at least relative to what I typically do. And I realized that we weren't having regular brown bag lunch meetings recently, and so I decided that I would go ahead and try and twist arms, and I wasn't very successful. So the only arm that was available to me was my own. So I decided I'd give a presentation on what I was doing at the time. It's an interesting presentation in that I'm investing a lot of time and energy in a new database. So these great big giant databases always take a long time to figure out how to work them. I mean, there's all sorts of complications and nuances. And it's also a sort of a discovery issue in that there's always some gems there that in these databases that you don't count on. And I usually plan on getting at least 2 or 3 articles from one of these big databases when I go into it, and sometimes more, sometimes once I know that database, then that sort of sits there, and I may go back to it later on when something else comes up, and you say, wouldn't it be nice if I could look at this? And I say, oh yeah, we could do that in relation to that. So I'm going to give you a little bit of an overview of what I'm going to do with this, but also a little bit of the overview of the project as well. Let's see now, does this work? Yeah, so the first slide is self-concept is important, and there's all sorts of good things, and you probably have already seen that slide several times before, and you can take my word for it that self-concept is an important variable, and there's been lots of work that's been done for a long time, and at least a fair amount of it has been done by me. And self-concept is a multi-dimensional hierarchical model with self-esteem at the top and academic and non-academic components. And the focus of my research has typically been on the specific academic components that are and academic self-concept that are most relevant to educational settings and educational psychology. But sometimes I look at the physical side, sport and so forth, and I guess some of the emotional stuff that I'm doing with Reinhardt. So I've traipsed around that hierarchical model, but mostly I'm looking at the academic side. There's a number of models that I've looked at. One is the reciprocal effect model. And this model says that there's self-enhancement, that having a good self-concept leads to future performance, and that future performance predicts future self-concept. And I sort of developed a paradigm for this, called the reciprocal effect model. It's a cross-site panel model, but I'm best known for what's referred to as the reciprocal effect model, which is specific to self-concept and achievement. And recently, as some of you may have realized, this has become very controversial in terms of whether this is the appropriate way to analyze it or not. And that's another story that we might talk about later on, but that's basically the reciprocal effect model. And it's pretty important. It says that self-concept is not only important in itself, but it also leads to, it at least predicts and presumably leads to other good things. Oh dear. That's the reciprocal effect model. And then there's the internal-external frame of reference model. And this is an interesting model. It says that to have a good math self-concept, I have to have good math achievement, but to have good math self-concept, I have to be better at math than verbal. And so verbal achievement actually contributes negatively to math self-concept and vice versa. And this has been replicated lots and lots, and so it's a fairly standard model. There's a couple of meta-analyses and good solid support for it. And this is the big fish, little pond effect. That's basically saying that it's pretty universal that students, but people in general, use social comparison. And if you use a social comparison process, it says that the contextual effect is on self-concept is going to be negative. So that the brighter I am, the better my self-concept. The brighter everybody around me is, the worse my self-concept. And this is just a table from one study showing how consistent it is. So this is actually one of the most consistent, cross-nationally consistent findings in education, maybe even psychology more generally. Okay, so I've started with this new database. It's got a lot going for it. It's big, 16,000 kids in year 10, 750 schools, and the last wave of data that they've collected is age 26. So there's some nice longitudinal data for it. This is part of the suite of studies that the US has done. So these are studies that are starting back in 1970s. That are these longitudinal studies going from 10 to 12 years. Most of them are somewhat ongoing, but typically they stop at age of 26, which is an interesting issue, and we'll talk about that one maybe a little bit. But in any case, this is just one of a large number, and there's some overlap between them, not nearly as much as you would want. The high school and beyond was something that I did a lot with, and I might talk about that. The NELS, I used that for a bit. Now I'm moving to the new one. It's got some interesting features. All right, so it's longitudinal to about trend. The cohorts were in sophomore year 10 and initially collected at 2-year intervals. And these are some of the things that are the focus of it. And it's longitudinal in that for the most part, the kids are staying in the same school, but they're followed up, and they did a really good job of following up. I mean, they've got up to more than 80% response for age 26. So for these kinds of longitudinal studies. It's also got lots of input. So there's input, the principals fill things out, 2 teachers fill things out, parents fill things out, and good response rates from all these multiple respondents. So there's some really interesting kinds of things that can be done with that as well. These are just some of the themes that I just cut and paste those out, but you can just take a quick look at that and you can kind of see what it is that they're looking at. And Jimmy, undoubtedly there's themes there that are relevant to most of your interests if you're interested in playing with this data and working with this data. Okay, so I'm focusing on the self-concept. They've got, there's an interesting issue as to whether this is self-concept or self-efficacy. I might talk about that if we have time at the end. I'm calling it self-concept, but they're actually calling it self-efficacy. In any case, whatever it is, it's a self-belief scale, and it's got the same items in math and English in year 10, and then math in year 12. Interestingly, I don't know why, there's a good English test and math and English in year 10, but in year 12, they're saying their focus is on mathematics. And so there's no English test and there's no math test, or there's no English self-concept in year 12, which is somewhat surprising, but okay, that's what it is. Okay, so there's each of the three models that I looked at, that I mentioned, I could look at possibly with this data, and I've been exploring that. But also notice that recent experience has taught me that overly inclusive studies are actually harder to publish. So when I looked at how complex the paper was evolving to be, I decided to break it into two papers. And so the first of those papers is the ones that I'm talking about today. And the second one will be probably a combination of either IE or big fish, maybe a bit of both. I mean, one of the nice things about this with looking at the big fish is to be able to look at outcomes at age 26. Let's see, these are just some, I was intrigued with this. I think a further study that I'm going to be looking at is looking at educational expectations. There's a lot of, so at year 10, they have educational expectations from almost everybody. So there's one from the kids, the students, there's one from mother, there's one from father, there's one from a math teacher, there's one from an English teacher. And then for the parents, not only do they have how far do you think they'll go, expect them to go, and how far would you like them to go? And I mean, there's some interesting stuff there about what happens to when parents are maybe overly ambitious, whatever. There's some interesting issues there. I haven't started looking at it, but there's some stuff about repeating a grade, and that might be interesting in relation to some of the work that I've done on some of the positive effects of repeating a grade and seeing if I can replicate that. Probably won't be able to because it isn't quite, the design isn't quite right, but I might look at that. And then they also have some stuff where they were asked to nominate their three best friends. And I don't know who they are, but they filled out little surveys about each of them, and the one I was kind of interested in is how important grades are to each of your friends. And so there's some interesting stuff there. All right, so what I'm looking at here is the reciprocal effect model, and that's a miniature version of what I showed you before, just so you can remember what it looks like. So there's lots of research that's looked at the reciprocal effect over relatively short periods of time, mostly while kids are in school. But mostly the reciprocal effect model has focused almost exclusively on self-concept and achievement. And I haven't looked at some of these long-term predictions. And so that was what I wanted to use this data to do. So the main variables are the reciprocal effect model variables. That's math self-concept and math achievement collected in years 10 and 12, waves 1 and 2. There's also lots of covariates. I use gender, SES, school average SES, and in some cases I used English achievement in year 10 as a covariate. Then there's the wave 3, the end of high school. Now this is interesting data because they got, for all the kids that were in either, that were eligible to complete either the year 10 or the year 12 survey, they asked the schools to send them the official transcripts, and they got 90% of the school transcripts, and they did lots of coding with that. And so that's a really quite interesting. So these are grades and coursework completion and things like that are based upon official transcripts rather than self-report. The variables that I've chosen to use for here was the final grade point average. The focus is on math, so the number of units in mathematics and the highest level of mathematics coursework that they completed. And then for the age 26 outcomes, there's educational attainment, educational expectations, and occupational expectations. That I'm calling that wave 4. So these are the correlations. These are all latent correlations. So they're mostly sort of corrected for unreliability, except for the ones that are, well, at least the self-concepts are. It's only the self-concepts that are multi-item ones. So it's only those that are corrected for that. There are some problems. I mean, that stability of over 0.9 for math achievement obviously is going to complicate things. It's going to be hard that's fine for the reciprocal effect model, but it's going to complicate things when I look at long-term predictions of wave 1. Obviously, anything from wave 1, some of it will have to go through that. I mean, math, wave 1 math isn't going to have much effect on much of anything other than indirectly through wave 2 math. Let's see. Yeah, I mean, self-concept is related to pretty much everything, at least modestly. The gender differences are what you'd expect. They're negative for self-concept, for math self-concept. They're positive. The gender effects are positive for reading achievement. Okay. All right, so these are the models that I looked at. This is the most simple, basic reciprocal effect model. This is adding covariates. This is adding reading achievements, and this is the whole-blown model. So the hypothesis is that there'll be support for the reciprocal effect model, that the cross paths in particular will both be significant, that these cross paths in particular, the stability paths will be significant, but so will the cross paths. And the prediction is that the covariates, the inclusion of covariates, won't have much effect on support for the reciprocal effect model. Okay, this is fairly important because particularly with this cross-like panel model, being able to show that covariates, controlling for covariates doesn't make much difference is important. And then this is the long blown out model. And so here I'm going to be looking at a fairly sophisticated way, or at least tedious way, of looking at direct and indirect and mediation and all that sort of stuff. So I'm hypothesizing that the wave 1 math achievement and math self-concept will have significant direct and indirect and total effects on end of high school outcomes, even after controlling for achievement, and that by age 26, the outcomes will be substantially or entirely mediated by the wave 2 variables. So these are results for the 4 models. So the effects are all significant in the right direction, although the stability paths are quite high for the achievement, but we saw that just the test-retest correlation was 0.9. So of course they're very high. And it's interesting that the effects of math these effects are fairly small, but I guess wouldn't be surprising that they're small given how huge the effect of time one achievement. So time one achievement correlates 0.9 with time two achievement. So there's not a lot of room to for any other predictors to get in. These effects are quite strong. In any case, there is good support for the basic model or for the basic predictions, and adding the more complex models doesn't change things to any great extent. All right, now these are the total effects for Model 4. So Model 4 is the outcomes in terms of wave 3 at end of high school and wave 4, which is age 26. Now, the total effects are the sum of the direct effects and the mediated effects. And so it's controlling for the covariates. So it's not surprising that they're substantial, but it's an important finding to say that these total effects are quite substantial, even for the age 26 sorts of variables. So if we look at attainment, self-concept is significant, but it's not nearly as important as math and reading achievement. Educational expectations, math self-concept is relatively more important, but still math and verbal achievement are more important, and to a similar extent, educational expectations. Let's see, so these are the number of units of math. Now, that's probably the strongest effect of math self-concept, although math achievement is still a bit stronger. So the total effects are large enough to be important. And then this gets kind of messy in that this is the for the effects of math self-concept time one. These are the total effects, which is the same thing that we just looked at. These are the indirect effects, and this is the total direct effect. So this is the path that you know. This is the regression coefficient if you just did a regression coefficient, and that's normally what you put in the model. But I'm arguing that it's really important in these models to look at direct and indirect effect. And in some cases, the direct effects of time one self-concept are bigger than the indirect effects. Bigger there, more or less the same. For the math achievement, the effects are mostly indirect. The direct effects, this one is actually significantly negative, although it's got a substantial standard error, and these are non-significant. But that's not surprising because mostly the effects of time one math achievement are mediated through time two math achievement because that correlation was so high. And this is the same thing for the year 26 or for the age 26 outcomes. And here, almost everything is mediated. The only significant direct effect is the effect of math self-concept time one on long-term educational expectations. That's an interesting one because these kids, they're not kids now, at age 26, these young adults at age 26 have educational expectations above and beyond their actual attainment at age 26. But I guess that's reasonable because I guess education is sort of an ongoing, lifelong kind of pursuit. So it's not maybe surprising that they have educational expectations that are beyond what they've done at the time. So main findings was their support for the reciprocal effect model, that the total effects of year 10 math self-concept were significant for all the outcomes at the end of high school and age 26, and that they had substantial direct and indirect effects on end of high school grades, but mostly the effects were mediated by age 26 long term. Limitations, it's a shame that that the data set didn't include math. It didn't include English self-concept and English achievement at year 10. So I could have looked at reciprocal effects of both of them together. That would have made it a much more interesting study. Self-concept is based upon self-report. Sometimes reviewers complain about over-reliance on self-report, but that's probably not too bad for self-concept. Age 26 is a strategic age, but it's still too young to assess some of the long-term accomplishments. So that, in fact, the educational and occupational expectations are for what's going to happen at year 30. And at age 30 would be a more reasonable time to look because people that have gone on and done higher degrees, university and master's degrees and PhDs and professional degrees and so forth. At age 26, they're just still getting ready to enter or only have recently entered the job market. So it's not necessarily whatever. And then another issue is that the reciprocal effect model is almost exclusively in educational psychology. And there's this is good and it's bad. It's good in that there's an established paradigm and lots of people have looked at it. And so there's systematic reviews and meta-analyses and stuff like that. So that bit is really good. But the kind of the bad part is that there's all these other models that are basically consistent with the reciprocal effect model, that this research needs to be integrated more fully into some of the other research. There's also the issue of whether I'm looking at self-concept or self-efficacy. Probably doesn't make too much difference in relation to this. I've done a pretty substantial study where I looked at the difference between self-efficacy and self-concept. And basically, self-efficacy, if you go by the original Bandura requirements of self-efficacy items, they have to have a well-defined task, and the standard has to be included as part of the item, and therefore you eliminate lots of the social comparison processes. So a self-efficacy item is at the next track meet, and I'm going to be able to run 100 meters in less than 13 seconds. And what's the probability that I'll do that? So you don't have to compare yourself with anybody else to answer that. Whereas the items here, there's undoubtedly social comparison processes that are inherent in the items. Let's see, particularly items that are asking, I can do an excellent job on math assignments. I mean, that's almost excellent is almost always going to be social comparison sort of process. So that's for this reciprocal effects model. It doesn't have a whole lot. It's not a critically important issue, but for the internal-external frame of reference model, and particularly the big fish, little pond effect, that distinction becomes really quite critical. And I was able to show that for pure self-efficacy items that are developed more or less according to Bandura's standards, those frame of reference effects mostly disappear, which is, from some perspective, is good, because it means that it's maybe a more absolute measure. On the bad part, once you control for prior achievement, academic self-efficacy items don't predict much future achievement. They don't do anywhere near as well as the social comparison. So the self-efficacy items eliminate much of the evaluative aspect of the self-belief construct, but that evaluative aspect is also what buys you a lot of the prediction. Okay, so that's an overview of that and of the presentation. Now let me see if I can figure out how to get out of sharing and open it up for questions.